Okay, so today we are looking at 5.2D. We are looking at cofunctions and calculating. I'm going to read you some stuff about cofunctions, and then we're just going to write down what they are. We're not going to actually write down and derive them. Two positive angles are complements if their sum is 90 degrees or pi over 2. Please put your masks on over your mouths and your noses now that you're done eating your rice cakes. Thank you. Okay, so two positive angles are complements if they add up to 90 degrees or they add up to pi over 2. So, for example, 70 and 20 are complements. Another relationship among trigonometric functions is based on angles that are complements of each other. Because the sum of angles in any triangle is 180 degrees, in a right triangle, the sum of the two acute angles is 90 degrees. Thus, the acute angles are complements. So, take a triangle, take away 90 degrees for your right angle. The other two angles are always going to add up to the other 90 degrees. If the degree measure of one angle is theta, then the degree measure of the other acute angle is 90 or pi over 2 minus theta. So we can always find, if we know the right angle and one acute angle, we can always find the other one because it's always going to be a complement. Because that relationship exists, we have what are called cofunctions. Sine is a cofunction with cosine. Secant is a cofunction with cosecant. And tangent is a function with cotangent. So the one that literally has the word co on the beginning of it. So those are our cofunctions. And how we can use those is that sine of theta is equal to cosine of 90 minus theta. So sine of theta is equal to cosine of 90 minus theta. Put degrees on that. Alternatively, cosine of theta is equal to sine of 90 degrees minus theta. So sine and cosine are cofunctions. So basically, if you know, let's say this is 20, sine of 20 is equal to cosine of 70, because 20 plus 70 is 90. So you take one angle, the other angle of it, and it's because it's the opposite over adjacent, or the opposite over hypotenuse becomes the adjacent over hypotenuse, basically. Okay, our next set of cofunctions is our tangent. Tangent of theta is also equal to cotangent of 90 degrees minus theta. Alternatively, cotangent of theta equal to tangent of 90 degrees minus theta. Mason. Okay, last one is secant of theta. Secant's cofunction is cosecant. So secant of theta is equal to cosecant of 90 degrees minus theta. Or cosecant of theta is equal to secant of 90 degrees minus theta. Those are all of our cofunctions. These and these are just opposite. Remember the ones that go together? That's literally sine, tangent, and secant. And then cosine, cotangent, cosecant. The word co is on the front of it. Okay. One thing, though, is this is in degrees. I put 90 degrees minus theta. You can, if you're in radians, just switch 90 degrees to pi over 2. So if in radians, switch 90 degrees to pi over 2, because those are equal. we are going to do 2 examples, one in degrees, one in radians, and then we are going to start calculating for the other thing that we are doing today, which is evaluating trig functions with a calculator. Okay, so first example, example 1, we are going to find the cofunction of sine of 72. Sorry, sine of 72 degrees. That's important. I tell you whether I'm in degrees or radians. 72 radians would be a ridiculous thing to look at, but sine of 72 degrees. Okay, so you say, what's the cofunction of sine? It's cosine. So then sine of 72 degrees, its cofunction that is equal to it is cosine of 90 degrees minus that 72 degrees. And then we literally just do 90 minus 72, which is 18. What? What?
I thought the F in the function was a J.
Oh, conjunction. Also, I spelled cofunction wrong, and I wrote confunction. Like a conjunction junction. Wasn't that a thing? Okay. A way you can check this if you are worried. We haven't put things in calculators. When we do in a second, we'll do this in a second. You can throw in your calculator and get a decimal. So literally, sine of 72, cosine of 18. Oh, hot dang, they're the same. Quick way to check it. Okay. And we'll do more with calculators in a second, so don't worry about that yet. Example 2. We are going to find a cofunction or a confunction or a conjunction of cosecant of pi over 3. Yeah, cosecant of pi over 3. Pi over 3 is 60. Yep. Because it's a third of pi, and so it's a third of 180. All right, cosecant, you say, what's the cofunction of cosecant? It's secant. So it's going to be secant of, and then we have to do big brain stuff. We have to subtract fractions. Pi over 2, because that's 90 degrees, minus pi over 3. What is the lowest common multiple and therefore the lowest common denominator of 2 and 3? 6. So we need to make them both have a denominator of 6. So I'm going to multiply by 3 over 3 and by 2 over 2. So I will have secant of 3 pi over 6 minus 2 pi over 6. 3 minus 2 is 1. It's going to be secant of pi over 6. If it is faster for you to say what Alder said, which is pi over 3 is 60 degrees, so that means it needs to be secant of 30 degrees. What is 30 degrees in radians? If that's faster for you, go for it. Do it. I don't care. Okay. last thing we're going to do today is we are going to do a bunch of stuff in our calculator. We are going to calculate sine, cosine, tangent, cotangent, secant, cosecant. We can calculate all of those in our calculator. Also, we are going to be given what sine, cosine, tangent are equal to and be doing inverse functions in our calculator. So I'll show you how to get to those too. Here is the most important thing, the thing that I told you. If you don't pay attention to this right now, your life is going to be miserable for all of trig. So everyone grab a calculator and everyone look up with their eyeballs. And let me grab one of yours because mine's the same like model as yours, but it's just a different, it's color and lit. That's why I use it. All right.
Most of these calculators are in radians.
So that's what we're talking about. Okay. So your calculator has to be in degrees if you want it in degrees, and it has to be in radians if you want it in radians. So this is the calculator that Noe is using. This is the calculator that the rest of you guys are using. Both calculators, you hit the button that says mode right next to the second button, and then you scroll down here. Let me get a very... You hit mode, and then you go down, and it's on radians right now. You hit enter, or you just like go back. If you want to go to degrees, you make it bold on degrees and hit enter. And then you can second quit and go back, and it'll be in degrees.
Or you can just put clear.
Yeah, you can also just hit clear. So you are going to get half of the questions wrong if you don't switch back and forth between radians and degrees as needed. If you get a ridiculous answer, like I was doing your assignment for tomorrow, I was like just working through it to make sure I liked all the problems and did enough examples to get you through all the problems. So I was doing that, and I had my calculator in radians when I was supposed to be in degrees and got like a distance of like negative 5,000 miles. And I was like, this seems wrong. So you have to make sure you switch from radians degrees as need be. So any questions about that? All right, so we are going to be able to evaluate trig functions. If it is sine, cosine, or tangent, you use the sine, the cosine, or the tangent button, and you type in either your radian measurement or your degree measurement. So my first example for us, we are going to find cosine of 48.2 degrees. So cosine of 48.2 degrees. So the first thing that you need to do is hit the mode button. Make sure you're in degrees. I already was. So go put your calculator in degrees. And then you literally just type cosine 48.2. You should get 0.6665. We have just summoned the devil. Okay. Any questions on that? Take a second to make sure that you actually can get that in a calculator and you actually know how to get from degrees to radians. Okay. Next thing that you need to be able to do is you need to be able to use a calculator to evaluate cotangent, secant, and cosecant, because your calculator only has sine, cosine, and tangent buttons. It doesn't have buttons for the rest of them. So here's what you need to know. The next example we're going to do, we are going to do cotangent of 1.2 radians. If it doesn't have a degree sign, it's in radians. So you need to know that if it doesn't have a degree sign, it is in radians. So cotangent of 1.2 radians, I almost just said degrees, we need to know that cotangent is the reciprocal of tangent. So we are going to type in our calculator 1 over cotangent of 1.2. But we need to put our calculator in radians. So mode radians 1 divided by, I was wrong. What? I'm having a rough life. Okay. Reciprocal of cotangent is tangent, so it's going to be 1 over tangent of 1.2. So 1 over tangent of 1.2. 1 divided by tangent of 1.2. Make sure your calculator's in radians. You should get 0.3888, which, in response to us summoning the devil, we have these 3 consecutive 8s, the most auspicious number. I don't know. I'm Asian, so 8 is the most auspicious number. Most auspicious. What does the word auspicious mean? I don't know. I just literally have grown up since I was like 5. Every time like the number 8 would come up, my family would be like, most suspicious. Conducive to success or favorable. Giving or being a sign of future success. Auspicious, yeah. Most auspicious. Oh, no. The number 8 is the most auspicious number. Okay. Any questions about sine, cosine, tangent, cotangent, secant, cosecant in a calculator? So for sine, cosine, and tangent, you would just type them in. For cotangent, it would be 1 over tangent. For secant, it would be 1 over cosine. And for cosecant, it would be 1 over sine. So it would be whatever the reciprocal is. What we've already done. Okay. The last thing that we're going to do in our calculator today is if we know what sine, cosine, or tangent of a certain value is, we can use that to find the angle. So, for example, let's say that we know that tangent of theta equals 26.0307. So, tangent of theta equals 26.0307. The question you are being asked here is to find theta in degrees. Find theta in degrees. On these, it's important that you read and ask and see whether it wants you to find it in degrees or find it in radians, because you have to have your calculator in the right mode. So, how we find theta, if we know what one of our trig functions is equal to, is we use the inverse trig function on our calculator. So that is the function above sine, cosine, and tangent. See the sine to the -1, cosine to the -1, tangent to the -1. So what we're going to type in our calculator is tangent to the -1 of theta, or sorry, not of theta, of 26.0307. And we need to make sure that our calculator is in degrees. So we'll go on our calculator. We'll go to mode, degrees, and we will type in second tangent, because that's tangent inverse, of 26.0307. And I get 87.7. It's got to be 8, because that's going to round it up. 87.8 degrees. And actually, never mind. When you're doing it in degrees, it tells you to round it to the nearest degree. So 88 degrees. Very auspicious. You would do the exact same thing if it was cosine or sine. You would do cosine inverse or sine inverse. You would do the exact same thing if you were asked to find theta in radians. You would just make sure your calculator is in radians to begin. Okay, that is it for today. Tomorrow we are going to apply things we have already learned, but we are not learning any new, like, how to do things. We're just applying it to, like, actual triangles and, like, angles of elevation and stuff. So that's it for today. Get started on today's assignment. And then tomorrow we're going to do applications, and then